What is queuing theory? Queuing theory is the mathematical study of lines. Not these types of lines, but more along the line of this type. By definition, queuing theory is a mathematical study of waiting in lines, or queues. The goal of the theory is to be able to predict the time it takes to wait in any given line. The most basic queue can be modeled with this diagram. The three large circles represent servers. The rectangles represent the people in line, and the arrows show the preferred direction of people in order to reach maximum efficiency. Ideally, to ensure the least amount of people waiting in line, each person will be equally distributed to each of the servers. What type of line do you think this is an example of? That's right, it's a supermarket. However, in most cases, it is more complicated than this. Leonard Ornstein, whose line of work was psychology of queues, came to the conclusion that each minute you wait after the third minute feels twice as long. This is why waiting in your hospital's lobby feels like an hour, when in reality it is usually only 15 minutes. Because of this phenomena, shoppers who wait in line longer than 3 minutes become impulsive. It is no mistake that stores include extra non-essential items by the checkout. They implement this retail strategy to make you forget how long you've been waiting in line. What affects the supermarket model is people's decisions. Have you ever decided to not stand behind someone with a full shopping cart when trying to buy just your milk? According to line psychology, this is called line jockeying. When someone proceeds to check out, they go to the line that is moving the quickest, not necessarily the shortest line. Another variable in the supermarket model is when the person ahead of you causes an unforeseen delay. Some of these examples can include the person ahead of you with a wallet full of coupons that the cashier needs to verify, or possibly it could be the cashier's first day on the job and makes a mistake which causes them to rescan the items. If you were already in line, you may decide to switch lines or just leave the supermarket altogether. This is called re-enging. The standard model for queuing system is as follows. This means the length of the line equals lambda times waiting time. Lambda is the symbol for arrival rate. In this simple equation, 4,000 equals lambda times 0.25 years. A factory produces 4,000 candy bars every 3 months. This means lambda equals 16,000 candy bars per year. If the workers in this factory worked for 250 days for 10 hours a day, then they would make 8 candy bars per hour. The equation would equal lambda equals 8 candy bars. This information can be vital to a company that is trying to figure out the labor force required to be most efficient. In a slightly more complex system, depends on the serving rate of the server. In this diagram, lambda still represents the arrival rate of patients. Q means the amount of people waiting in order, and mu, the Greek symbol, means the service rate of the doctor. The regular discipline for this circumstance is FIFO. FIFO stands for first in, first out. However, there are many other disciplines, like LIFO, which stands for last in, first out. This discipline can be used to complete the shortest tasks first. For example, if a bakery makes 100 loaves of bread on Monday and 100 more on Tuesday, they may want to sell the newest loaves of bread on Wednesday instead of letting both groups of bread to get old. Priority discipline is serving those with a higher importance first, regardless of when they arrived. You see this most often in emergency rooms. You will never see someone having a stroke waiting for a doctor who is treating a patient with a stomach ache. Processor sharing is serving all tasks at once. This is most common with Wi-Fi, because many computers can use Wi-Fi at the same time instead of waiting for a computer to finish using the Wi-Fi, stopping, getting off the Wi-Fi, and allowing another computer to go on the Wi-Fi. The next part of my presentation, I will go over real-life examples of queuing theory. Many of you have called your favorite restaurant for delivery. In this situation, I will be using Domino's Pizzas as the restaurant of choice. In 2007, Domino's had lost popularity to its rivals, so they revamped their supply chain. Needless to say, the pizza company had a lot on the line with this new idea. The first thing you need to know is the steps Domino's takes to complete your order. Let's say you first call and order a medium pizza with Cinnasticks and garlic bread. Your order is then prepped. The employees then bake the pizza, the Cinnasticks, and the garlic bread. Once all three are completed, they check to make sure if it's up to their satisfaction. Your deliverer will then use the nearest neighbor algorithm to deliver every order that's in the car. Domino's has consistently received positive reviews regarding delivery time, when in reality, the pizza chain is no faster than its closest competitors. People view Domino's as being quicker due to some queuing theory psychology. Domino's has a track your order feature. They provide up-to-the-minute updates for your pizza, which does two things. The first being that it relaxes you, so you're able to see exactly what phase your order is in. It also prevents unnecessary phone calls to Domino's asking where your pizza is, which takes away from the Domino's answering the phone for new customers. This allows Domino's to become more productive as they are allowed to take more orders. After you place your order, they ask you to complete an interactive survey. Although this survey is short, it causes you to forget about when you place the order, and it provides Domino's with useful information. Many companies hire a whole team of analysts to help solve inefficiencies with the hope to create a more successful business. Another example of this is in an apartment building that recently added 50 new units but received many complaints due to the long waits for the elevator. Because you cannot simply add more elevators to a pre-existing building and not being able to increase the speed of elevators due to safety codes, the solution for this problem required much more thinking. Before going any further, it's important to know the basic properties of queuing psychology. Unoccupied time feels longer than occupied time. Process waits feel longer than in-process waits. Anxiety makes waits seem longer. Uncertain waits makes waits seem longer than known. Unfair waits are more equitable, Unfair waits are longer than equitable waits. The more valuable the service, the longer the customer is willing to wait. Solo waits feel longer than group waits. Knowing this, the team of analysts proposed adding mirrors near and inside elevators, and a small floor tracker inside the elevator. The mirrors distracted people, which helped alleviate the boredom of waiting for your elevator. People would check their hair and look at themselves, which distracted them. And the floor tracker allowed people to get a rough estimate of how long they needed to wait. This discovery was game-changing in terms of lines. To this day, almost every elevator you enter either has a mirror or a floor tracker or both. My last example of queuing psychology are the lines at Disneyland. Most rides at Disneyland show an estimated wait time, which allows someone to decide whether the wait is worth their time. Disneyland uses a queuing formula to create estimated wait time. It goes as follows. Wait time equals arrival rate divided by service rate times service rate minus arrival rates. Here are some queuing theory equations. When waiting at the DMV with C number of service channels and a random number of people waiting and a random number of people arriving, the total wait time can be followed with this formula. Expected wait time equals expected arrival rate minus 1 divided by service rate. The formula to find how many people waiting in line can be modeled as expected number of people in the queue equals expected random arrival divided by service rate plus lambda over mu, which is arrival rate divided by service rate. Do you have any questions?